Good morning, my friends. I am Vishal Kashyap. Today I am discussing about the function, the graph of the sum function. Now, in the previous class, we discussed about the real function or real valued function. A function f is said to be real valued function if its mapping on R to R, that is real number to real number. So this function is known as the real valued function. Such as we discuss the sum graph of this function. In this way, first of all we discuss about the function f such that R to R such that fx is equal to x. This function is known as the identity function because here the function fx is equal to the fx equal to x. This function is known as the identity function. The domain of this function, if we suppose a and b be two function, a and b be two function, then a is also real function and b is also real function. So the mapping 1 1 2 2 minus 1 minus 1 minus 2 minus 2, this function is known as the identity function. In this function we know that the domain of f is equal to the R and the range of f is also R. Here the domain is positive, negative, any real number, and the mapping also positive, negative, and the any real number. So the graph of this function is, look at here, x and fx equal to x. Putting the value of x in this function, if x is equal to minus 2, then fx is equal to also minus 2. X is equal to minus 1 here, so fx is also minus 1. If x is equal to 0, then fx is also 0. 1, this is the 1, and 2, this is also 2. So we plot the graph as y-axis and horizontal is x-axis, x dash, and this is the x, y and y dash. We plot here the point minus 2 or minus 2. X is equal to minus 2, 1, 2 here, and 1 and 2 here negative. So the point 2 and 2 lies here, this point. So this point is minus 2, minus 2. This point 1, 2, 3, and this is also 1, 2, and 3. So this point is minus 3, minus 3. Also, this is minus 1, minus 1. This point is 0, 0 as origin, and this point is equal to the 1 and 1. So x is 1 here, and y is also 1. This point is x is here 2, and y is also 2. So this graph is a straight line. The graph of identity function is, look at here, in this is known as the graph of identity function. Now we discuss about the constant function, the graph of constant function. The second function is constant function. Let c be the fixed real number. Let c be the fixed real number, then the function f such that R to R, this is the real valued function, such that fx is equal to the c for all x belongs to R. This function is known as the constant function because here fx is equal to c and c is a constant number. Obviously the domain of f is equal to the R because if we are taking the two sets a and b, and we take, suppose for an example, we take fx is equal to 2. So here 1, 2, minus 1, minus 2, 0, also lies 2, 2, 2, 2 and 2. So the range is here 2 and the domain is any real number. So the domain of f is equal to R and range of f is equal to C, singleton C. As the mapping of any number, any real number is C. Here C is equal to taken as 2. So the graph of this function is represented here. Suppose this is the function fx is equal to 2 and we taken here x and fx. We take 1, this is the 2, minus 1 also 2, 0 also 2, 2 is also 2. So we have draw the graph of this function here 1 and 2, 0, 2, minus 1 and 2, 1, 2 and so on. If we taking the points, we find that this is a straight line which is parallel to the x-axis. So this function fx is equal to c. This is the graph of constant function. Now we discuss about the third function. Now we discuss about here. Please note it. This is the function of constant function. This is the graph of constant function taken here as a parallel of x-axis. Again, the polynomial function, a function of the form of fx is equal to a0 xn plus a1 xn minus 1 plus a2 xn minus 2 plus so on xn an xn, where n is non-negative integer. Okay, here the x, the power of variable, is a non-negative integer, and a1, a2 and an all belongs to R is called polynomial function. So the function is said to be polynomial if it is the form of a0 xn plus a1 xn minus 1, a2 x minus 2 and so on an xn. Again, we find that the domain and the range of these functions, where the f says that R to R says that fx is equal to x square for all x belongs to R. This is the polynomial function. But here the form of a1 xn, a1 is here 1 and the value of n is 2, so 2 is non-negative integer. So in this form the domain of f is equal to R. Because in any set, if you taking any real number, map these numbers is a square of this number. So the domain is R and range of f is equal to the x belongs to R such that x always positive, because a square of any real number is always positive and greater than 0. So the range of the function is here f is equal to x belongs to R such that x is greater than or equal to 0. Now we are taking the graph of these functions here. Now the function is fx is equal to x square. So x here and fx is equal to x square. Putting the value of x in this equation, we find that here x is equal to minus 2. So if we take here x is equal to minus 2, so minus 2 square is also 4. So minus 2 and 4. If we taking here the 1 or minus 1, in both the cases the square of this is equal to the 1. So the minus 1 if we take here, so minus 1, the square of minus 1 is also equal to the 1. So minus 1 here is 1, and 0 we taken here the value of x. So the square of 0 is also 0. If taken the 1 is also 1, and if we take the 2 here, x equal to, then 2 plus the square of 2 is 4. Now plot the graph of this quadratic equation, because the variable of power 2 is called quadratic. If the variable has power 3 is called cubic, and if the variable power 1 is linear. So the graph of this quadratic equation here, this was 2 and the 4, 1 2 3 4, 1 2 3 4, we taking the point 2 here, 4 1 1 minus 1 1, and 1 is also 1, and 2 is also here, 2 is 4. So the joining of these points, we find that this graph is a parabolic. So the graph of the polynomial function is parabolic. If the cubic has also the graph of the form of this much. This is the form of the cubic polynomial. We draw carefully. Suppose if we take the fx is equal to the x cube, so this function is also known as the polynomial function, and the graph of fx is equal to x cube is the form of this much. We plot carefully and we find here the polynomials, graph of the polynomial functions. So polynomials has linear, quadratic, cubic, biquadratic. So we take the variables in any real number and draw a graph on this process. We find here the graph of polynomial function. Next is rational function. The function of the type fx by gx. The function of the type of fx by gx, where fx and gx both are the polynomial function of x. It means that a function which is the form of fx by gx, where fx and gx are polynomial function of x, defined a domain where gx not equal to 0. Here noted to be point here, gx not equal to the 0. Now we take some examples. For example, let f such that r minus 0. This is the real function excluding 0. If we include 0, then the value of gx will be 0 and the function is an infinite. So the f says that r minus 0. This means that a real number not included 0. It means excluded 0. Such that r such that fx is equal to 1 by x. Now this is the function fx equal to 1 by x in the form of here, the form of fx and gx for all x belongs to r minus 0. Then the domain of this function such as fx equal to 1 by x is here the domain of f r minus 0. So all the value of x excluded with 0, and the range of f will be r minus 0, because the function is not defined as gx is equal to the 0. Now we take the graph, draw a graph of fx equal to 1 by x. Now x is, and this is the fx equal to 1 by x. The value of f is putting here and find the value of fx. Now we take first the x is 4, then this is 1 by 4. If we divided 1 by 4, we find that minus 0.25, as is 1 divided by 4, this is equal to 1 is divided by 4, so this is 0.0282 5. This is equal to minus 0.25. Again, if we take x is equal to minus 2, then we find here the fx is equal to 1 by minus 1 by 2 is also minus 0.5. If we take x 1 minus 1, so the value is also 1 by minus 1 is equal to minus 1. Similarly, we put here the value of x as minus 0.5 to get minus 2. If we put here the value of x is 1, so the value of fx is also 1. If we take the value of x is minus 0.25, so we find that this value of is equal to 4, and so on. So this is the value of x and this is the value of fx. These two values, that is the x and this is the y, we take the graph here and plot it. Suppose this is the y-axis and this is the x-axis. Here the x dash, this is the x dash, and this is the x, and this is y, and this is y dash, and we plot these values of this graph. So we find here the graph of this function is the form of this much. The next, we add here the other functions and draw a graph. Write down. The next is the graph of the modulus function. First of all, we define it. What is the modulus function? Now let f such that r to r. This is f is the real valued function such that fx is equal to mod x for each x belongs to r. Then fx is equal to mod x where is equal to x where x is greater than or equal to 0 and minus x where x is less than 0. So the function fx is equal to mod x is known as the modulus of function. Now we discuss what is the range and the domain of the modulus function fx is equal to mod x. Now we define the mod domain f is equal to the r, as suppose this is the two set. So here 1 minus 1, 2 minus 2, any real number we take here. So the domain of f is r, and the range of f is, if we take the minus 1 is also 1, 1 is also 1, 2 is also 2, and minus 2 is also 2. So the set of all non-zero negative real non-negative set of non-negative real number. This is the domain of f is a real number, and the range f is the set of non-negative real number. All non-negative real number in the set. Now the graph is drawing here. X and fx equal to mod x. If we take the value of x is equal to 1, so this is also 1. If minus 1, then it is 1 as the modulus function. So any positive greater than or equal to 0 is equal to the x. So minus 1 here take to 1, 0 is also 0, 1 is taken here. So mod 1 is also 1, and if we take the 2 x equal to, also find the 2. Now the graph of this function. Now this is the y x-axis and this is the y-axis. Here taking the point 1, minus 1, 1, 2, 3, minus 1, minus 2, upward plus and downward minus 1, 1. This is point 1, 1, minus 1 and 1, minus 1 and 1. This is the point here. 0, 0 is the origin. 2, 2 and minus 2. And if we take the x equal to minus 2, it is also 2. So join these points and we draw a graph of the modulus function. So this is the graph of modulus function. Next function is the signum function. First of all, we define it. The function f such that r to r, this is the real function, real valued function, such that fx equal to 1, 0, minus 1, 1 when x is greater than 0, 0 when x is equal to 0, and minus 1 when x is less than 0. Therefore, this function is known as the signum function. Here fx is equal to again 1 if x is greater than 0, is equal to 0 if x is equal to 0, minus 1 if x is less than 0 is called signum function. Now we discuss what is its domain or range of this function. Here suppose a and b, suppose here if 1, 2, minus 1, minus 2, any numbers, so the domain of f is R. But if the value of x is equal to 0, then it's 0 is mapping on 0, 1, that is x is greater than 0, so it mapping 1, 2 also mapping 1, and greater than 1, all numbers are mapping here 1. So the range of the function, that is the signum function, is the range of f is equal to minus 1, 0 or 1. This is the range of the function and this is the domain of the function. After we draw a graph, so first of all we have here x is equal to 0, this implies fx equal to 0. If x is less than 0, this implies fx equal to minus 1. If x is greater than 0, this is fx equal to 1. So 0, 1 and 0 minus 1 do not exist here, as we take the x equal to 0, so it is equal to the 0. So 0, 1 not exist, not lie on the graph, and 0 minus 1 also not lie, because if we take the x equal to 0, so it is also equal to the 0. Now we draw a graph. So the graph is here. If it is as constant function, so the constant function as is equal to the minus 1 or 1 or 0. So 0 does not exist on the graph, so this is the constant function graph, and minus 1, this is not equal to 0, but it is the graph of here. So this graph, as it is x dash, x, y and y dash. So this graph is known as the signum function graph. Also here remember the point here 0, 1 and 0 minus 1 not lie in this graph. The next graph is discussing. The next is greatest integer function or a step function. Greatest integer function or a step function is defined as if x belongs to R, that is real valued function, then the greatest integer not exceeding x, greatest integer not exceeding x is denoted by this much. This is the notation of greatest integer function, denoted as this much, as suppose here 3, greatest integer 3 is equal to 3. If taking 2.01, this means greatest integer is here 2, so this is equal to 2. 2.9, this means greatest integer is here 2, so this is equal to 2. If we take here 2.99, then also this is equal to 2, because the 2 is the greatest integer. So in greatest integer we see here, if greatest 2.01 greatest integer here 2, so this is equal to 2. 2.9, the greatest integer here 2, so it is equal to 2. Minus 1.3 here, minus 1.3 is the greatest integer is minus 2, not minus 1. Here be careful, here minus 1.3 is equal to minus 2 as the greatest integer. Now greatest integer x is equal to, see here, minus 2 where x is greater than equal to -2 and less than -1. That is -1 when x is greater than equal to -1 and less than 0. If it 0, then x is greater than equal to 0 and less than 1. 1, this means x is here greater than equal to 1 and less than 2. 2.9, x is greater than here 2, then x is greater than equal to 2 and less than 3. So here, see here, if x is 2.01, so this is equal to 2 and 2.9 is also 2. If we take 2, this means x is greater than equal to 2 but less than 3. This is known as the greatest integer function. Now we take here the domain of f. We take any number as in a domain. So domain of f equal to r, real number, but the range of f is equal to the set of all integers, because here if we take any point, suppose 3.8 here, this is equal to the 3. If we take here minus 1.5 is also equal to -2. So all this form is as the form of the set of all integers. Now we draw the graph of this function, greatest integer function. For example, fx equal to the greatest integer function x. Here fx equal to -2, this means x belongs to close interval -2 and open -1. This is included -2 but not -1. -1, x belongs to -1, not included 0. If 0 take here, and x belongs to 0 but not 1. If we take 1 and x belongs to 1, not 2. Now the graph of this function is plotted here. This is origin 1, 2, 3. Here -1, -2, 1, 2, -1, -2 take here. And this point here, if we take 0, 1, 0, if taken here, -2, if we take here -2 and -1, -2, not -1, x is equal to -2, -2 here, -2 but not -1, so here not valid, -1, 2, -2, 2, not valid here, -1. If we take 2, then this is not 2 but 1 to 2. Here 1, this means 1 not 2. So this is the graph of a step function or greatest integer function. Now today I am discussing about all the graphs of some functions, some important functions. It is most useful graph because the next class we discuss about the continuity and differentiability of the function. So remember it. Thank you for watching.